Hello everyone, welcome back to my YouTube channel. I am Manpreet Singh and I am back with another lecture of projectile motion. I have uploaded two lectures of projectile motion. The first lecture I have introduced you about the projectile motion and its significance and all. In the second lecture I have told you about the trajectory of projectile motion and its equation, derivation and the Galileo's law of independent motions. And in today's lecture we will going to discuss about the derivations of equations for projectile motion. So there are three equations which must be asked in your examinations, and that is total time of flight, maximum height attained by the projectile, and the maximum range. So we will discuss all these three things in today's lecture. So please watch the lecture till the end so that your all doubts will be cleared and all the formulas and all the derivation is clear. Yes, correct. So let us start with the video. Let us start with the very first equation, that is time of flight. So first of all, this kind of question can be asked in your paper for sure short 5 marks. So for that you need to first of all draw a proper diagram. So proper diagram can be like this. So this is a proper diagram that you have to draw before starting the derivation. So this is the parabolic path which the projectile takes: y-axis, x-axis, range, height and the total time of flight. And this is the initial velocity components. I have magnified it. I have magnified this portion. I have magnified here. So this is the initial velocity. Angle is theta with the horizontal. Remember that in sometimes in questions you are asked that this angle is from vertical, so you have to take the horizontal angle. So keep in mind the language of the question also, correct? So this is the angle theta, correct, which is taken from the horizontal and it is the initial velocity components, u sine theta and u cos theta. I hope you have attended all the lectures of vectors so that you can split the vectors. You understand this, that is u sine theta is from here to here. I have taken from this point to this point. Clear? So this is the point. So you have to draw this first, and now jump on to the derivations. So first of all we will derive the equation for time of flight. So what should we do? So in my opinion you should do the horizontal component. Take the horizontal direction motion, because you can also take the take the vertical direction. Sorry, take the vertical. I misused the term. Take the vertical in this derivation. You can take also the horizontal as well, because the time is same. Because the time is same, rather you take horizontal or rather you take vertical, no matter what you take, the time is same. Yes. So lekin I should prefer you that take the vertical. Yes, take the vertical motion. Yes. So what should we do? Remember that I have told you that in the vertical motion, in the vertical motion there is acceleration due to gravity acting downwards, acting downwards. Yes. And in the horizontal motion there is no acceleration at all, that is, it is a uniform motion. Velocity is constant. This u cos theta component is constant throughout the motion, correct? But in the vertical motion there is acceleration, that is, the velocity is not constant in the vertical direction. In the vertical direction velocity is not constant, it is changing at every instance. Yes. So g is acting downward, acceleration is there, hence it is non uniform. non-uniform. Keep writing all these things. It will help you a lot. Yes, in the vertical direction it is non-uniform. So let's take the derivation. Let us jump on to the derivation for what? For time of flight. Time of flight. Yes, capital T. So I have told you that you have to take the vertical direction motion. So let us take the vertical direction motion. I am writing here vertical direction motion. Vertical direction motion. So what is happening in vertical direction motion, if you see carefully, that in the vertical direction there is no displacement. Aren't you notice it? Aren't you notice it? There is no displacement in the vertical direction. Why? Because here it is also 0 comma 0. Yes, and here it is what? R comma 0. R comma 0. X comma y. Yes, x में ये R चला, but y में क्या चला? What is the displacement in y? Displacement होता क्या है? What is displacement? Displacement is the change in position vector. Change in position vector is the displacement. So what is the change? 0 minus 0. There is no displacement for the whole motion. There is no displacement in the y axis. See, what you think, so what do you want to think, that you have to split the motion. You have to split the motion. See, this is a 2D motion, so you have to think the y direction motion and the x direction motion, that is vertical and horizontal, separately. You can think separately because both are independent of each other. Galileo's law, remember Galileo's law? So both are independent from each other, so you can think both of them independently. Yes, so it doesn't matter that in the x direction it covers r displacement, so it must be that y direction has also some displacement. No, it's not like that. In y direction there can be 0 also, the displacement, but in x axis there is r. Yes, there is r. The displacement is simply the position coordinates also. You can say that it is position coordinates. So here it is also 0, here it is also 0. So in y direction there is no displacement all, no displacement at all. I hope it is clear. It is very clear. So if you apply second equation of motion here, second equation of motion, why to apply second equation? Because you have to find the time, you have the initial velocity, displacement in vertical direction is 0, acceleration due to gravity, so you can apply second equation of motion. So by second equation of motion, what you get is, my handwriting is somewhat, please बहुत गंदी handwriting है मेरी, थोड़ा सा देख लीजिए, कोई बात चलिए. So second equation is s equals ut plus half at square. You have to find the t. Yes, you have to find the t. S in y direction, u in y direction, a in y direction. So s in y direction is 0, u in y direction is u sin theta into t, capital T. Vertical motion मतलब total time of flight, capital T, minus, because g is acting downwards while the velocity is upwards. Yes, velocity is upwards while the g is acting downwards, so it is negative. So minus 1 by 2 g capital T square. Yes, is this clear? Is this clear till here? Yes. So now take this side, half gt square equals to u sin theta capital T. Cancel the t terms. Yes, so what is remaining? t equals, take 1 by 2 g to this side. So t equals 2 u sine theta upon g, and that's the answer. That's the answer. That's the total time of flight by a projectile motion. Yes, by a projectile motion. Now now there can be also another way of solving this question by first equation of motion. Yes, फर्स्ट इक्वेशन ऑफ मोशन से भी आप टोटल टाइम निकाल सकते हो, लेकिन क्या होगा उसमें, व्हाट हैपन्स देयर इज दैट द वेलोसिटी दैट कम्स आउट देयर इज, सॉरी, द टाइम दैट कम्स आउट देयर इज u sin theta upon g. Why u sin theta upon g? Because when you use the first equation of motion, you consider u as u and v as 0. Why? Because at the topmost point final velocity becomes 0. Yes, so you can use the first equation of motion also. U is given u sin theta, vertical, remember vertical, ये चीज़ याद रखनी है, vertical, u is u sin theta, v is 0, vertical, a is a minus g जो भी, and t is you have to find. So when you find the t, you this is your homework. You have to find t from the first equation of motion. From the first equation of motion, when you find the t, it comes out to be only u sin theta upon g. Why? Because you have considered only this motion, only this part you have considered. So you have to multiply it by 2 u sin theta upon g, and that's the correct answer. Because of symmetry of motion, you know that half the time here and half the time there, because the distances are equal and so on. Yes, so I hope that's clear, and the total time of flight, how to find it, how to derive it, it is also clear, very much clear to you. And you can find it out by second equation of motion or by first equation of motion by taking the vertical direction motion. Yes, take the vertical direction motion and everything will be sorted. Yes, so this is the total time of flight. Now let us proceed to derive the equation for what? For h max, for the h max, that is the total height gained by the projectile motion. Yes, so let us proceed. So I hope that the first equation, that is the time equation for the projectile motion, is very much clear to you. Now we will proceed to discuss the height. Yes, the maximum height attained by the projectile motion. So its equation we have to derive. So let us derive the equation for the maximum height. Yes, again we have to take the same thing, that is the vertical direction, because maximum height is in the vertical direction. Yes, maximum height is the vertical direction. Y axis, this comes out to be something about x comma y component. So y is the maximum thing. We are neglecting about x, we are not considering the x. What is the x is there for which the y is maximum, we are not considering it, but the y is the maximum here, y is the maximum here. So we have to take the what? We have to take the vertical direction. Yes, we have to take the vertical. See, when you throw something up, so naturally you have to take the y direction, you have to take the vertical direction. So yes, you have to take the vertical direction for height, and this is compulsory. For time you can take the horizontal direction as well, because in horizontal as well you can find the same time being the independent of motions. But in case of height derivation, you must have to take the vertical direction, not the horizontal. If you take the horizontal, you can't find y, you can't find h max. Either you can find r and write that r equals h max, and that's the wrong thing. Yes, so take the vertical direction, take the, I will write here vertical direction. Again vertical direction you have to take, vertical direction motion. Now my handwriting is something better. Yes, so in vertical direction what happens here is this. Now what equation you have to take. See, first equation of motion you can't take. Why? Because there is no distance term. Yes, this is the distance actually. This is the distance. But in first equation of motion there is v, u, a and t, not a distance at all. In second equation you have distance, but then it is something like complicated. Why? Because it is a quadratic equation. S equals ut plus half at square. That square term is something mm, complicated, because t is actually 2u sine theta upon g, then you square it to 4u square sine square theta upon g square, and that's very very complicated. So what you have to take is the third equation of motion. Why third equation of motion? Because in third equation of motion v जो होगी आपकी, that's zero. Why? Because at this point vertical, remember the direction you have taken. Vertical final velocity is zero at the highest point, and you have to find the displacement for the highest point. Yes. So what are the things? uy because vertical direction, vertical बार बार बोल रहा हूँ. uy is u sin theta. Students keep confusing these things. Why? Because they don't understand that you have to take y and x axis differently. You have to treat them differently because of Galileo's law. And this is the advantage of projectile motion, not the disadvantage. Please not consider it as a disadvantage or as a burden on you. This is an advantage. If the vertical, suppose if the vertical motion is dependent on the horizontal or vice versa, so what happens? Everything becomes chaos. वाई एक्सिस एक्स पे डिपेंड कर रहा है, तो वाई के लिए एक्स की इक्वेशन क्या होगी, मतलब ये वो मतलब बहुत ही कॉम्प्लिकेटेड हो जाता है. बट नाउ यू कैन ट्रीट इज वाई एक्सिस एज अ स्ट्रेट लाइन and x-axis as a straight line. That's why your textbooks are giving you the first chapter kinematics in 1D, then 2D, because first of all you have to understand the 1D motion, then 2D motion, and in 2D motion you have to apply the same equations, same mindset, same things, but in two different directions. बस सिर्फ 2 बार आपको वो चीज़ें करनी है. बस आपको ये सोचना, you have to understand what the thing I should take, vertical or horizontal. And when you have taken your direction, stick to it. When you are taken the direction, I have taken vertical direction, so all these things, all the parameters, velocity, आपकी height, displacement, final velocity, acceleration, everything should be in vertical direction perspective, not the horizontal. Yes. So uy equals u sin theta, and vy equals 0. Why? Because at this point there is no vertical velocity, and a equals what? A equals minus of g, due to the thing that the velocity is upwards and acceleration is downwards, so a equals to minus of g. So now you have to find the thing because of the third equation of motion. Apply the third equation of motion. So what you are doing? V square minus u square equals to 2as. Vy square, that is 0, not interested, minus u square equals to 2g, and s is what? S is h, capital H. And remember that g is negative, so negative sign comes here. Yes. 2 into minus g, तो माइनस को मैंने बाहर ले लिया. Yes. So minus to minus get cancelled. So what the answer? H equals to, ये uy लिख दीजिए आप यहाँ पे, H equals to what? U square y upon 2g. And what is uy? U sin theta. So u square sin square theta, I have squared both the terms, u square sin square theta upon 2g, and that's the H max. Is this clear to you? I hope this is clear and this is visible too. Yes, this is visible. I hope this is visible. U square sine square theta upon 2g. This is the h max. And what we have done, take the vertical motion, write all the parameters, take the third equation of motion or apply the third equation of motion, and then simple mathematics, and you get the answer h max equals to u square sine square theta divided by 2g. Now the third thing is your range, maximum range. Now only you have to take the horizontal motion, but the interesting part is you don't have to take it. Why? You don't have to take the, you don't have to, मतलब परेशान होने की ज़रूरत ही नहीं है कि x एक्सिस में क्या करना है. Why? R is the distance. Yes, in the horizontal direction. So velocity, and that is the initial velocity in the horizontal direction, is ux, that is u cos theta, and time you have find out, time is 2u sin theta upon g. So what's the problem? You have to find r, you have velocity, you have time. This is uniform motion. This is uniform motion. In remember all the things. That's why I have discussed one proper lecture for the properties of projectile motion, for its characteristics, what is uniform, where is uniform, what is the vertical direction, what is horizontal, where is this acceleration, where the velocity is changing, where it is not changing. I have discussed all these things. So in x direction, velocity is uniform, u cos theta is all through the motion. You have time of flight, total time of flight, so you can find the total distance. Remember this formula? This is the 8th standard formula. Frankly speaking, 6th standard formula. Velocity equals velocity to vertical, speed equals distance upon time. So what's the matter here? You have to find speed, तो फिर इसमें क्या हो जाएगा, distance equals velocity into time. So this r becomes ux into time of flight. Yes, speed into time is distance. Speed into time is distance. Ux is u cos theta. Time is 2u sin theta अपॉन g. यहाँ कर रहा हूँ मैं. उसके बाद क्या आ जाएगा, 2u इधर, u इधर भी है, तो 2u स्क्वायर साइन थीटा cos theta upon g. You can also write this, but if you know a little bit of trigonometry, if you know, then you can also write it as 2u square, sorry, 2u square, only u square sine 2 theta upon g, and this is the range formula. This is also the range formula. 2u square sine theta cos theta upon g, or you can write u square sine 2 theta upon g. क्वेश्चन पे ऊपर डिपेंड करता है आपको क्या दे रखा है, क्या नहीं दे रखा. ठीक है. एंड यू हैव टू रिमेंबर द ट्रिग्नोमेट्रिक फॉर्मूला. 2 sin theta cos theta is sine 2 theta. Yes, this is the whole derivation for time of flight, for maximum height, for maximum range. This is the thing that you have to remember. You have to note it down. You have to practice it a minimum of 3 times for remembering the things. I know this is a little bit of difficult and not easy to remember, but the thing is, our human mind is very strong. If you remember the things, if you revise the things frequently and practice it more, you can remember all the concepts that is discussed in your syllabus. Yes, this is the truth. So you have to practice it a lot. You have to solve numericals on it. You have to practice this derivation at least 3 times, at least 3 times. One one today, one yesterday, and one you have to do next week to check your माइंड, कि आपका माइंड में घुसती है बातें कि नहीं घुसती है, और घुसती चिंता मत कीजिए. योर माइंड हैज़ इनफ स्पेस दैट इट कैन होल्ड अ होल encyclopedia in it, a whole encyclopedia. So that's all for today's